Every day, countless dogs are returned to shelters. One of the main reasons a shelter dog is returned is due to a mismatch of dog temperament and its potential owner's lifestyle. This project aims to help dog shelters and pet adopters determine the energy levels of an adoption candidate dog in order to find its ideal home. To do this, we conducted a formative study consisting of 2 iterations to determine if accelerometer and tug sensors placed on a dog's leash, collar, and harness can collect data that can be used to quantify the energy of a dog through its lunges. The study also served the purpose of showing us which metrics have the most observable potential in helping visualize dog energy levels. We utilized wagon sensors, which are wearable adaptable growable grid of interconnected nodes created by GVU researchers. These are designed for wearable systems that allow us to quickly attach sensors to a featherboard for quick studies. We hypothesized the best placements of these sensors, testing multiple locations, but ultimately ruled that the collar, back of harness, and bottom of the leash are the best areas to run in the study due to its staying power, as dogs tend to break sensors, and their closeness to the dog. We ran 2 iterations of the study. The first day we tested the accelerometer and tug sensors separately by presenting Ratchet, our test dog, a treat. This was to see if we could get any quantifiable and distinguishable readings from the sensors that corresponded to his movements. The second day we ran the test, but this time with Ratchet tethered to a stationary object, as holding the leash ourselves proved to increase errors. Our results revealed that the tug sensors had not been outputting the proper values. Fixes we made to the wagon library code failed to alleviate the problem in time to run another trial. However, we were able to get meaningful data from the accelerometer. Results from the first iteration showed acceleration along the x-axis and acceleration along the y-axis, readings that were more profound than g-force along the x-axis and g-force along the y-axis. These showed better readings from the wagon sensors when placed at the back of a harness. Yet results from iteration 2 counter this by showing better readings from placement on the bottom of the collar. We believe that the methodology of iteration 2 is more reliable, but would still like to conduct further verification. In the next steps of this project, we plan to embed the sensors in a final design and run tests with more dogs to see their movements in a more natural setting, exposed to both humans and other dogs.